But then using that oscillation method has several limitations. For example, say there is a crazy surgeon who wants to change the position of the knee joint. He wants to change it to probably the middle of the shank. And he wants to know the moment of inertia in this situation. And if that's a crazy surgeon, he's going to do the job like right now. But we don't want to do that. We just want to simulate the situation. So there are several methods that we can actually calculate it without doing the experiment. So you don't need to do the experiment every time when you want to know the moment of inertia around that axis of rotation that you're interested in. So this is the equation we're gonna use, which is called parallel axis theorem. We're not going to go deep into how to prove this theory, but if you're interested, you can Google this on Wikipedia, and I think the description is kind of clear. So anyways, this is the equation we're gonna use. Ixx would be the moment of inertia about axis of rotation, and that axis of rotation is changeable, so it depends on what do you want to put the axis of rotation at. And ICM is the moment of inertia about center of mass. So that's the Ixx in this situation. That's a moment of inertia in this situation. The center of mass of the baseball bat is here. We're going to put the axis of rotation right at the center of mass, and we're going to get the moment of inertia in this situation. That moment of inertia is ICM, and that should be a constant value because center of mass is not changing, right? So the axis of rotation will be put here, and each object would have only one ICM. So that's about the object. And m would be the mass of the object, L would be the distance from axis of rotation to the center of mass. So if you get ICM, like if you get ICM of this object, then you can calculate, like if you move the axis of rotation here or here at a grip or here at a head, you can calculate without doing the experiment. You just plug in the L, which is the distance between the center of mass and the axis of rotation that you're interested in. But we're going to do it reversely today. So we have Ixx calculated already, right? And you have the distance between center of mass and the axis of rotation. You got a mass of the object. So plug in the equation, you should be able to get ICM. So that's what we want to do today. In exercise 1, you've got moment of inertia of two objects around two ends, right? And you're going to put the Ixx into this equation to calculate the ICM in that situation. So put Ixx here, M here, L here, and you got ICM with a little bit high school math. So here comes a question. That's a super important question. Would the ICM be the same in these two situations? That'll be the same object, the baseball bat, rotate around the grip and rotate around the other end. Would you expect to see the same ICM in these two blocks? And the answer is yes, because the definition of ICM is moment of inertia about center of mass. And the center of mass is a constant value in one object. So if that's baseball bat, the center of mass is at there. It's not changing. So you'll get the same ICM, right? So the ICM is not changing if you didn't change the object. The ICM is the same in the same object. That's a super important concept. So that's why if you have the ICM of one object, you can calculate the Ixx easily without doing the experiment. Okay, so let's go to the assignment section. There are 3 tables, 2 in exercise 1 and 1 in exercise 2. And below each table, you'll see this description that will show your calculation for obtaining something for something. So There are several situations in these two exercises, but you just choose one situation to show me your calculations. So for example, in exercise 1, there are 4 IXX you gotta calculate, but just show your calculation for one situation. And also for ICM, just show your calculation for one situation. And also there are 6 questions you gotta answer in the assignment. And one question is here. That's usually we discuss in in-person classes, but I'm just going to give you the answer right now, but I'm going to talk about it verbally. So you gotta think about it. I'm not gonna type it in my PDF. So the question is, state at least 3 experimental assumptions that were made to estimate the moment of inertia. So which is about this experiment. We swing the baseball bat. We need to think about 3 assumptions before we put it into the equation. So one assumption would be there is no friction at the axis of rotation. So there is no friction. If there is friction, you cannot use this equation. So we assume it's super smooth. And the second assumption would be this is only 2D movement. So the baseball bat is only moving here on the on the 2D view. So it's not moving inside and outside of your screen here. This is only moving on this plane. So that's a second assumption. And how about the third assumption? Third assumption is about some math background of this method. We're not gonna touch that deep, but just remember the assumption is that the angle is pretty small. So the angle is less than 5 degrees. If the swing angle is more than 5 degrees, you cannot use this equation. Okay, so again, 3 assumptions: no friction at the axis of rotation, and also it's only 2D oscillation, not 3D oscillation. It's not rotate, it's just swing. And the third assumption is that the angle do not exceed 5 degrees. Okay, so that's all about it, and have fun. Okay, don't hesitate to email me if you got any questions. Bye bye.